Hello everyone, welcome to my YouTube channel. Today we are going to discuss about big O. What is big O of 1, big O of log n, what are these terminologies, and how we can conclude by just seeing an algorithm, what is the time complexity of that algorithm. Okay, what is big O notation and why does it matter? This is a definition which I took from Wikipedia. In plain words, time complexity is the time which is required by your algorithm to run, and big O notation is like it will denote how your algorithm is scaling, whether it is varying linearly, whether it is varying exponentially, whether it is varying logarithmically. Okay, so let's see an example and we'll just try to understand how we are denoting through big O. Suppose you are copying some data from the internet. Suppose you need to download a 250 KB book from the internet. So okay, so it will require just 1 second or so. If you are going to download a book of 1 MB, then it will require approx 4 to 5 seconds. Now suppose there are a bunch and collections of books you need to download and the total size is approx 100 GB. Then the time required will be very much high. Alright, so here you can see as the data size increases, okay, the time required also increases. Now we see a second case where you need to copy the data from your friend's hard disk because your friends had downloaded all these books already. So what you need to do is you need to go to his place, you need to carry a pen drive, you will just copy the book and come back home. Suppose you want the 250 KB book, then you will go to his home, you will copy it in your pen drive and then you will come back. Okay, so time required is suppose K. Now suppose you want the 1 MB book, then you will do the same step again, you will go to his place and then you will copy it again in K time. If you want the 100 GB book, the same time. Okay, so here the time of traveling and the time of copying from your friend's computer to your hard drive, okay, if you remove that time, the total time required for the data is constant. So the amount of time required remains constant. The data size, okay, doesn't has any impact on the time. Okay, even if it's a 150 GB or 200 GB, the amount of time required remains constant. And in mathematical terms, if you want to denote the time required by this algorithm will be K. Suppose this data is not 250 KB, 1 MB and 100 GB data, it is your input. Then as the input is increasing, the amount of time required by your algorithm remains constant. That means T, the time required by algorithm is K. But in the first case, as your input is increasing, the time required by your algorithm also increases. Okay, so that means you can denote it as n times K. If your input is increasing n times, then your time requirement is also n times. So if you want to denote the second condition, it will be big O of 1 constant function, and for the first case it would be big O of n. Okay, let's see the tips and tricks. Okay, so different steps get added while you are giving the notation, big O notation. You need to keep these tips and tricks in mind. You need to drop all the constants, you need to drop all the non-dominant terms, okay, and different input will have different variable. Not every time it will be like big O of n, big O of n square, big O of n log n. Okay, it can be big O of x depending upon the variable name and the algorithm. Okay, so let's see first a basic example. Okay, suppose you are given a sorted array, okay, of 100 elements and you need to search an element 10. Okay, so this algorithm will run in constant time because the first position you will have 10, so it will just pick the 10 and it will return you. Suppose instead of 100 there are 1000 elements, then also the time taken by the algorithm will be constant only because at the first place you will get 10. Suppose you have 10,000 elements also in an array, it's a sorted array, so n will be 10 and it will be at the first position. So the time required for this condition will be big O of 1. Alright, every time whenever you run the algorithm, immaterial of the size of your array, you are getting 10 at the first position, then it will be big O of 1. Okay, now come to a second condition where you are checking for a number 70. So now 70 will not is not present at the first place, so you need to traverse from 10 to 20, 30, 40 and then you will come to 70. So in this case you have traversed and this algorithm will require a time because you are searching. Okay, you are not searching, you are not getting the element at the first place, but you are getting it at the 7th place, so you required some time. Now suppose you are searching an element n equals to 120 which is not present in this array. That means you will traverse from first position to the last position and then you will come to know this element is not present. Alright, so suppose the length of the array is n, then you have to traverse the array n times. So whenever you denote big O is nothing but summation of all possible runtime divided by number of possibilities. If the length of the array is n, then the number of possibilities will be n plus 1. N will be n time traversing the array, n plus 1 will for the condition if the element is not present. So mathematically we can denote is like, if the element is present at the first position, it will require k time. If it's the second, then 2k, third position 3k, for the nth position nk. Suppose it is not present in the array, then plus nk. And if you resolve it, it will be, if you take out k common, then it will be 1 plus 2 plus 3 plus the whole series plus n. Okay, so you can just denote it as n into n plus 1 by 2. Okay, if you resolve it, it would be n square plus 2n plus n. So 2n is a non-dominant term here, so we'll just remove it. So the total time will be k by 2 into n. Okay, so k by 2 is constant, to be come out, the output comes out to be n. So the total complexity of this algorithm linear search will be big O of n. Now let's move ahead. We'll see an example. Okay, so don't go for the syntax of this code. This is just a pseudocode, and all the questions we are going to discuss today are pseudocodes. Don't go for the syntax. We need to just have an idea by seeing the algorithm how we can come to a conclusion of the time complexity of that algorithm. Okay, here an array of size n is given. Okay, we are having a for loop and we are having an if statement for each element in the array. That means for the worst condition, you're traversing the whole array. That means if you need to denote, it will be big O of n. And if condition is a constant time function, it will run one time. Okay, it is not dependent on the size of the array, so it will be denoted by big O of 1. The total time complexity here will be big O of 1 plus big O of n, and big O of 1 is a constant time function, so we can drop this and the total time complexity will be big O of n. Now we will go forward for the second example. Here we are given an array of size n. We have a for loop here and we have another nested for loop here. For the first for loop, we are going to traversing from 0 to n. Okay, so here the big O notation will be big O of n complexity. For the second part, again it is traversing from 0 to n. The time complexity will be 0 big O of n. But for every value of I, like I equals to 0, the for loop will traverse from 0 to n. Again I will be incremented to 1. Again this for loop will traverse till n. Again the I will be incremented. So for every value of I, this inside for loop will run. So the total complexity will be big O of n into n. Okay, and that will be big O of n square. Moving to the next example, you can see here like we have two for loops. Okay, so the total time complexity of this algorithm will be O of n square. And if you come to this conclusion by just seeing a nested for loop, then it is wrong. All right. So if you see the question, array 1 is of size n and array 2 of size m. So that means the complexity of the first for loop will be big O of n, then second for loop will be big O of m. The total time complexity will be big O of n into m. Okay, so don't get confused with always using big O of n. Just see the variable names and then decide what will be the time complexity. Here array of size n is given. Okay, you have a constant time functions, then you have a for loop which is traversing from 0 to n. So the first step will be, we'll denote as a constant time function big O of 1, and for the for loop we'll denote as a big O of n. The total time complexity will be big O of 1 plus big O of n, that is nothing but big O of n again. We are dropping the constant time function, that's why total complexity is big O of n. So we are coming to a next example. Now this example and the next example will be related. Okay, so we have a constant time function here, then we have a for loop, then we have a for loop. So the first for loop is starting from 0 to n, array of size n. Okay, so it will be denoted as big O of n. For second for loop, again we will denote it as big O of n. These two for loops are not nested, these are different and they are traversing fully, okay, independently. So that means the total time complexity of this algorithm will be again big O of n. Alright, moving ahead, we have an array of size n. Here if you see, we have some functions and then we have a for loop. The first is the constant time function, we will denote it as big O of 1, and the for loop it is times from 0 to n, so then its complexity will be big O of n. Total complexity of this algorithm will be denoted as big O of n again. Now coming to this question, you have a function again. So you have one for loop, you have second, you have third for loop. Okay, the first for loop is traversing 0 to n, array of size n, that means it will be big O of n. For second, it is traversing again from 0 to n, that means it will be again big O of n. For the third also big O of n. Now in the bottom condition, see you have nested for loops, that means the total complexity here will be big O of n square. The total complexity of this given algorithm will be O of n square plus O of n. Now O of n is a non-dominant term because O of n square is too much big. That's why we will drop this O of n. The total complexity of this algorithm will be big O of n square. Alright. So now coming to this question, we have a function where you have if n equals to 0 return 0, n equals to mat dot floor n by 2. That means you are dividing your n. Suppose the value of n is 8. That means it will be divided into 4, then 2, then 1. So whenever each step is executed, the number is divided. Like for the first step, 8 is divided by 2, then 4 is divided by 2, and then 2 is divided by 2. So what we are doing is we are performing iterations, okay, iteration 1, iteration 2 and iteration 3. So 8 is broken into parts. You required 3 attempts. Okay, if the n was 16, then you will require 4 iterations to break it. If the n is 2, then you will require 1 iteration to break it. What is the total? 3 iterations, 4 iterations, 1 iteration. This is nothing but the log. Okay, so if you see log of 8 to base 2, the value will be 3. 2 cube will be 8. Okay, so that way you can understand it simply. Okay, for such type of questions where you are breaking the element, if you are doing binary search, okay, so then the total complexity will be big O of log n. Suppose the n is 16 here, then you will require 4 iterations. If it is 8, you will require 3 iterations. Suppose it is 100, then you need to divide it into 50, then 25, then 25 into 12.5, the same way till 1. So that means a big number of 100 you are breaking into 6 steps. A number 16 you can break into 4 steps here. A number of 8 you are breaking into 3 steps. What is this 4? What is this 8? What is the 6? The number of iteration, total number of iteration, it is nothing but the log. Okay, so let's see this question. You have a function and inside it we have a for loop and then we have a while loop. Okay, so 0 to n. Okay, suppose the length is n or the array length, total number of elements is n, then we will denote it as big O of n. Now in this while loop, what we are doing is we are again breaking the element. Breaking the element means it will time complexity will be big O of log n. The total time complexity of this algorithm will be big O of n log n. All right, we'll go to the next question. Okay, here the list of length n is given. So we have some constant time functions here, then we have a while loop, then we have a if loop. Okay, so at this time you should be able to just denote it directly. Okay, so first will be big O of 1 again. Yes, in the second case we have a while loop which is index less than list dot length. You are traversing from 0 till length. Okay, that means it will be big O of n again. And we have a if else loop, that is a constant time function. So again you will denote it as big O of 1. The total time complexity of this algorithm will be O of 1 plus big O of n plus big O of 1. That means dropping the non-dominant terms and constant terms, you will get the total time complexity will be again big O of n. Okay, coming to this question, right, it's a function. You have been given a constant term, you have a while loop, then you have a for loop. Okay, first constant term, again it will be big O of 1. For second, if you see, you are just breaking the element. Okay, breaking the element, binary search or something, the time complexity will be big O of log n. For third part, you are transitioning 0 to y is nothing but n is the total length of the array, then it will be big O of n. The total complexity required here is big O of n log n. Alright, thank you for watching this YouTube channel. If you found this video interesting and useful, please subscribe to my channel. Thank you for watching.